Hello and welcome friends. In the lecture 1, we got introduced with the basic concepts related with land surveying. Now, in this particular lecture, we wish to discuss one of the important surveying techniques, that is traversing. Here, we'll be discussing about its definition, various types. We'll come to know about what method we have to follow in order to select the various stations, where we can make use of this particular technique, how it can be carried out, and what are the kind of checks that we can apply. So in the last lecture, we simply got introduced with basic techniques in surveying in the form of traversing, triangulation and trilateration. So here, as I said, we'll be discussing about the traversing. So we thought of traversing as one of the surveying techniques in which we'll be making use of series of survey lines. As such, the traverse could be open, that is, the starting station may not be necessarily ending station, and this kind of traverse is suitable for road works, pipelines or any such running structure the way we discussed previously, whereas it could be certain closed traverse in which the series of survey lines will be forming one closed loop as such. So it would be polygon of number of survey lines. While carrying out traversing, we have to be very particular about selection of the stations. So here just we'll discuss about some broad lines for the selection of the survey stations. So surveys could be carried out in all the seasons according to the requirement. But once survey is done, the land on which that survey was carried out could be required to be accessed according to the requirement of the projects. Hence, preferably the stations that we wish to define should be accessible for all the seasons. It is quite probable that we'll be having certain objective in the mind. Objective based classification already we have discussed. So say here just we wish to determine the say topography. For that we are using certain equipment, say for example theodolite. Now here the theodolite would be in some specific setup requirement, as well as to suit with the requirement of determination of the topography. There will be certain say things that we have to attend to, and hence here the station should be compatible with the objective, the kind of the method that we adopt, as well as even the equipment that we adopt. We also discussed about the principles of the survey, that is to work from whole to part, as well as fixing station by making use of at least two independent measurements. So we have to make use of that principles while choosing the surveying station for traversing. As well as we see here, there is certain stations A, B, C, D, which is forming certain closed loop A, B, C, D, A, and it is establishing control on this particular piece of the land. Now, in order to have this particular piece of the land subsequently surveyed, it could be required to have it divided into, say, some small portions. For example, here I have considered some, say, two triangles. So as we go for these particular series of triangles, so accordingly here we'll be able to establish certain secondary network as such. So here we must be in a position to establish certain preliminary work followed by certain secondary network followed by even certain say tertiary network. So here the kind of survey stations we will be choosing should be allowing us to establish the subsequent secondary or tertiary networks. One of the prime requirement is the stations that we define should be visible from each other. It establishes the control on the work as well as it facilitates the measurement of the distances in between that particular stations. So even if that particular piece of the land that we are considering in between two given stations, it should be preferably obstacle free. In order to facilitate the distance measurement, even the ground should be preferably flat as well as say firm, obstacle free, so that here we'll be able to set the equipment on the given station comfortably as well as we will be able to work in between the given stations. As many as stations are there, that many adjustments that we have to do. So in order to reduce the repetition of setting of the stations as well as plotting of the stations, even collection of the stations and even the related manpower to attend that particular station, we have to keep the number of stations to be optimum. It should be suitable with our objective as well as here the number should be such that we will be able to establish the control on this particular station. For example, for the piece of the land that I have considered here, the number of the stations that are optimum are say 4. I could have chosen some another triangle, say station A, station B and station C. It could have established the control, but some of the portions could have been difficult to survey. So here even I could have gone for certain pentagon in order to carry out the survey, but number of stations 4, like the way I have shown here, will be helpful in order to carry out that particular survey. In addition to the series of survey lines that we have considered here as AB, BC, CD, DA, we should be able to have one more survey line which will be dividing the entire piece of the land in 2 halves. So the way you see line AC here or line BD here is helping us to have some central line. So here this particular line will be assisting us in order to establish some different additional controls on piece of the land that we wish to survey. We'll be discussing about it later. As you see here, it is forming certain X. So even the formation of such X will be helping us to establish better control on that particular piece of the land. Here, the way you see the angle ABCD, which is included angle for the traverse ABCD, should be such that angles are not too acute or too obtuse as such. Now, here as we define the station, it will give rise to survey line. With respect to this particular survey line, we will be making use of some lateral dimensions in the form of offsets, which could be making angle of 90 degrees with major survey line. Hence it is called as perpendicular offset or simply offset, or it would be making angle other than 90 degrees, say for example 45 degrees. So accordingly here it will be say oblique offset as such. Here these particular offsets, if the feature is away from the cerebral line, unnecessarily it will demand the long offsets, and hence there will be say some proportionate error involved, and hence we have to see that these particular offsets will be having again the optimum length as such. We are talking about this particular say formation of this particular X, as well as allowing certain long line passing through this particular say traverse that we define. It will assist us to create some additional subsidiary station. So the way we were discussing about avoiding the long offset, we can establish certain tie. We can establish as such subsidiary stations which will be able to have certain say offsets with respect to that subsidiary lines or tie lines. Even we can have some additional stations established in the form of check station, so that the distance that is measured here on the ground, and once the feature is reproduced by making use of this traverse on the paper, as such the distance measured on the paper should tally with each other. So here it establishes some check on the work. One more feature is we must avoid trace passing. We should not enter into the other's land, as well as it is necessary to maintain the isolation of that particular work. Say for example, if that station is accessible to lot many people, unnecessarily they will be visiting the site and we are subjected to some undue question and answer. Even if there is a considerable flying of the vehicles nearby, it is quite probable that our equipment will be disturbed. So here we have to use our common sense in addition to some of the technical requirements. The way I am trying to present here the selection of these particular survey stations in the context of traversing, it is also applicable for all the kind of survey networks that will be adopting to survey the piece of the lands. So here, if we are going for certain total station survey, if we are going for certain plane table survey, if we are going for leveling, if we are going for certain say theodolite as such, all the things that we are trying to discuss here will also be applicable, and accordingly here that should be say observed while selecting the survey stations. So traversing the way I discussed here, it is technique of the surveying in which there will be series of survey lines which will be forming certain closed loop, or it will be forming certain open network. And here the directions and the lengths of this particular survey lines are to be measured with angle measuring instrument, as well as here certain distance measuring instrument as such. This kind of the technique will be suitable for all the kind of the works. Say for example, here I have tried to show certain campus. For that, just one traverse triangular network is enough to measure lot many features that are lying around. In addition, there could be very small piece of the land which is giving some details of some trees or small structures. So for that also we can make use of this particular traversing technique. The same could be extended over some other areas. It could be very helpful for certain road network or pipeline or any such say running feature. Say for example, even there could be some nala, there could be certain say river or any such say natural feature for which we can carry out this particular traversing. In addition, here just we can have certain say small feature, and with respect to that we can establish some such network. So what I mean to say is the traversing is that way very versatile technique, and it can be adopted for almost all kind of the networks immaterial whether it is just small piece of the land or even it is big city. So essentially we wish to make use of this particular traversing technique in order to establish horizontal control. But here, just to get introduced with technique, we can think of lot many similar applications. The list is that way limited, but here the kind of scope of this particular traversing is not limited. So here we can make use of traversing technique for the determination of existing boundaries, to locate the position of the boundaries, to determine the area that is encompassed by the traverse. We can determine the positions of the various land features in order to prepare certain plans or maps. We can make use of this technique in order to establish certain ground control or even advanced surveys. We'll be touching this particular concept as we proceed further. But just to understand this, or just to get introduced with this, say for example we are dealing with say photogrammetry. We are trying to have photographs of certain say piece of the land. So in order to link that particular photographs with respect to the ground network, we can establish certain ground network initially. Same could be photographed on the photos. So subsequently that photographs will be used in order to survey or to understand the features in relation with the network that is defined on the piece of the ground. There could be various utility surveys. So say for example, we are dealing with certain gas mains. We wish to lay down certain gas mains. We wish to lay down certain sewer network. We wish to lay down certain water supply network. So here, in order to have that design, there would be requirement of piece of the land that we are working with. So here just we can collect the data related with that particular say utility aspects. Similarly, for all the kind of construction works, we can make use of this set technique. Even in order to locate the various stations, we can make use of this traversing technique. So in order to have this particular traverse done, there are a lot many methods. I would like to recall the definition of surveying here. It is an art of determining relative positions. So art is not a certain specific thing. It will vary from person to person. It will vary from equipment to equipment. So by making use of plane table, we can go for traversing. By making use of chain, we can go for traversing. We can club in making use of compass with the chain to carry out this particular traversing. We can make use of transit, tachometer, total station, and accordingly we'll be able to name that particular say traversing technique as such. As we collect the data by making use of traversing technique, by using any of such equipment, ultimately we have to prepare, plan or map the way we discussed. It is our basic objective of surveying. So in order to plot the particular stations, we can make use of angle and distance, or we can make use of coordinates of that particular stations that are different. One thing we have to sure about, before plotting the traverse, it should be checked for the correctness for its linear as well as the angular wedges. As we apply the check, we will come to know whether the distance that is measured and that is actually existing is lying either in say reasonable limit of the acceptability. So here, if there are certain small deviations, certain corrections can be applied depending on the kind of the equipment and the method that we have used for traversing. Even we'll be discussing in depth for the corrections to be applied or getting known about the errors in the work in our subsequent presentations. So in order to go for traversing, we have to follow some specific steps procedure wise. We may be having certain information in the form of say for example topo sheet. So this particular topo sheet gives the details of the piece of the land, these particular things can be treated as the products that are of GTS survey, that is Great Trigonometrical Survey. So here the kind of the geodetic work that is done, and accordingly these particular set toposheets that are produced can be used in order to understand certain prevailing information. Otherwise, one can carry out the reconnaissance. That is, one can go visit the piece of the land, one can collect certain basic data, very similar to selection of the stations. Reconnaissance is the basic step of all the surveys that surveyor is supposed to do. Even we'll be discussing these particular details in depth subsequently. As we thought of selection of the stations, here these particular survey stations should be placed as close as possible to the features to be surveyed. So for example, the way you here see, this is certain river that is flowing. So accordingly, the network of the survey lines in the form of this particular open traversing will be very useful to collect that particular data. So accordingly, here this particular network is flowing parallel to this particular feature under consideration. So here we can make use of this particular open traverse by having the stations very close to the feature under consideration. Once these particular stations are selected, that should be firmly fixed by making use of either wooden or steel pegs. Depending on the kind of the work, if the work is of very important, the stations could be permanently marked by making use of certain stone or certain concrete structures. These structures are called as monuments. Here, the way you see, the structure is created in certain specific manner. It is fixed in some kind of the concrete. It is covered with some material so that it won't be disturbed, and in order to facilitate the surveying operation, it is provided with certain stake and certain nail mark so that one can work on this. Whenever the survey is completed, this particular structure will be remaining under buried condition, and one may have that referred by making use of certain location sketches, as it is called. Here one can have these particular things fixed as permanent markings which are engraved on certain concrete or even certain stone slabs. Necessary information will be written over that particular permanent marking. So here it will be kept flushed with the ground, and this will be very precise station mark. Especially whenever we deal with geodetic kind of the work, this kind of monuments will be essential task for the permanent location of stations and even some benchmarks which are nothing but points of known elevation. So, in order to carry this particular reconnaissance, one has to examine the terrain to be surveyed, select suitable sites for measurement of the baselines. So baseline is the line on which the network of the triangles is constructed. So that is important line, because with respect to that we will be computing all other dimensions, and that's why here there is a necessity for definition of this particular baseline. I hope you remember about allowing certain central line through the piece of the land to be considered, formation of the X, the way we discussed, it also goes with selection of this particular suitable site. Even the selection of the suitable positions of these triangulation stations, the way we discussed about this particular importance of marking of the stations for certain triangulation or geodetic work. So accordingly here just we can think of certain suitable positions as well as this particular intervisibility, Even uh, we have to select certain conspicuous, well-defined natural points for certain intersected points. So we thought of establishing certain subsidiary stations. We thought of establishing certain, say, check lines. We thought of establishing certain tie lines. So here there is a necessity to define these particular, say, tie stations or subsidiary stations. In addition, there could be certain, say, dominant station prevailing on the site in order to have certain features referred to. So we'll be discussing more about that, but such natural points will be assisting for elaborating our surveying operations. So that's why here there could be necessity for defining these particular, say, natural stations. In addition, here we have to collect certain information for certain miscellaneous aspects, like how the stations can be accessed, what are the various transportation facilities that are available, what arrangements can be made for the food, water, etc. during the surveys, what kind of labor that can be procured on the site, if there is a necessity to live on the site, then what could be the possible camping grounds. And nowadays, as we are making use of even certain electronic distance measuring equipment or total station or such things, today there could be a necessity to know that what could be the nearby station, which will be the source of the fuel, which could be source of the electricity, and even if required certain medical facilities and lot many such similar things. So to say, if we have to execute certain kind of the work, as we discussed about the phase of surveying, well before we have to understand what could be the necessity. So whether the given piece of the land and the nearby facilities cope up with our requirement should be studied in terms of the reconnaissance of survey. The subsequent steps that needs attention for that traversing to be done is measuring certain reference bearings and horizontal angles with certain repetition or certain appropriate method, and check the included angle sum on site itself. So the way you see here, there is, say, network A, B, C, D. Just for example, there could be network A, B, C, D, A. The way you have defined depending on the piece of the terrain that you are dealing with. So here, firstly, we have to define the magnetic north direction, and accordingly, here we have to determine the angle of that survey line, based on which we'll be able to determine the coordinates of the respective stations, or we will be able to work out the, say, included angles or such means in order to plot that particular features. The next thing that is essential is to measure the distance in between the stations. So here, distances need to be measured in to and fro manner, as well as over the day, and in fact for all the seasons, to ensure that the distance measured is correct one. Here, the person who is holding the tape, chain, or even could be the centering of the equipment at initial end should be very particular. The person who is holding the other end of the chain, tape, which are nothing but the measuring means of that particular distance, or dealing with the other end of measuring means, should be very particular, and simultaneously he should keep on recording all the entries in the field book. Once the surveying operation is completed, that is measuring of the angle, measuring of the distances, measurement of the bearings, one should draw some rough sketch which is depicting the piece of the land on which that we have worked. Such a sketch that is drawn on the site in relation with some dominant feature or naturally existing magnetic north is called as site plan. Here you can see that with respect to certain important station, two independent measurements are taken in order to define this particular station. This goes according to the second principle of survey, as you remember. Here, this thing assists us in many ways. It will be helping us to plot the network as well as to establish check on the work. In addition to this, one is supposed to prepare certain location sketch. So the way you see, this is the station, or rather it is one of the stations that is used for establishing the control on piece of the land. So for that particular station, we have to make use of two independent measurements to plot that particular station under consideration. And in order to confirm the location, here we can make use of certain, say, third measurement. So here we should see that the features that are used in order to measure the distances up to that particular station should be more or less permanent in nature. That could be tree trunk, that could be electrical pole, that could be certain, say, structure that is existing. So any specific building corner can be used in order to fix the location of that particular station. So drawing the location sketch and preparing the site plan and maintaining the field books are good habits of that particular survey corporation. As we plot the network, it should be exact replica of the network that was defined on the ground. For that, we have to apply certain checks on the traversing technique. Here, for the closed traverse, the sum of included angles should be 2n minus 4 90 degrees. So say for example, here as we consider triangle, so n is 3, which is nothing but number of sides. So here as we get 2 into 90 degrees, that is 180 degrees. I hope it is clear to you. Similarly, here you can check with pentagon. So here it will be 540 degrees. On the similar terms, sum of excluded angles, exterior angles as they are called, should be 2n plus 4, 90 degrees. The algebraic sum of the deflection angle should be equal to 360 degrees. Say for example, let's consider this as survey line AB. Now, with respect to survey line AB, survey line BC is deflected rightward through this particular angle. Hence, this becomes angle of deflection. As we consider this kind of, say, terminology, so accordingly, here this would be considered as, say, deflection angles, and sum of this particular, say, deflection angles should be equal to 360 degrees. It is quite probable that angle could be rightward or angle could be leftward. So say station A, station B, station C, station D, station E. So here this line DE is deflected leftward with respect to survey line CD. As such, here the right angle deflections would be considered as positive and left hand deflections would be considered as negative. In addition, the forebearing of the last line should be equal to its back bearing plus or minus 180 degrees measured from the initial stations. To start with, of course, we will be discussing lot many things about the compass, bearings and their types and things. But here, forebearing is an angle that is measured with respect to magnetic direction for first line of the network. So, in the direction of the survey, the way we measure the bearing, it will be called as forebearing. If it is measured in the reverse direction, it will be called as back bearing. Here, the way we thought of survey line AB, so this is magnetic north direction. Say this is angle alpha measured rightward towards line this particular AB. Hence, alpha is nothing but magnetic bearing for survey line. It is also forebearing of line AB. For plane surveys, magnetic north will be parallel to the direction that we have considered at A. So here, this will be north direction. With respect to that, we have measured bearing at station B towards A. That is, it is for line BA. As such, as it is measured in the reverse direction, it will be back bearing of line AB. So, here the forebearing of the last line should be equal to its back bearing plus or minus 180 degrees measured from initial station. For linear measures, survey line should be measured once on 2 different days in opposite direction, the way we discussed earlier. The measurements by chaining or by other method should also tally. For an open traverse, there are no direct checks the way we considered it for closed traverse. Here, there is a necessity to apply certain, say, indirect checks. So, here we can make use of this particular cutoff line for open traverse A through G. So, we have considered 2 cutoff lines here, line AD and line DG. So, here we can make inducing this particular cutoff line, we are virtually closing this particular traverse. So, here the traverse can be treated as A, B, C, D, A. So, whatever the things that we try to apply for closed traverse, that can be applied for this. So, this is the advantage of this circle, say, cutoff line as such. I hope you remember about choosing certain dominant natural feature the way we discussed about the selection of the stations. So, say here, if it is some such natural feature that is existing nearby this particular surveying network A through F, we can take the directions from at least some, say, dominant positions of the stations like A, B, C, D, E, F as such, and accordingly this particular station could be considered as auxiliary station. So, here the length and bearings that are measured from this particular, say, selected station should be also checked once the feature is plotted on the paper in the form of plan. So, here, say for example, direction AP that is measured on the ground, as we plot the feature P by making use of this particular measured direction and the measured distance, the subsequent BP direction should pass through that. So, here it will be establishing the additional check on the kind of the work that we will be carried out. So, this was the entire discussion related with traversing technique. So, dear friends, this is very important technique, and whatever the concepts that we have discussed for the traversing are to be used for all the kind of traversing networks that we'll be discussing in, say, our subsequent lectures. So thanks for your attention. The way we discussed about the traversing technique, in the subsequent lecture, in the next lecture, we'll be discussing about triangulation and trilateration. So bye till then. I wish you very happy learning and thank you very much.